Hi, Spring fans. In the last two videos, we've looked at how to support queries, possibly the most common operation in a GraphQL application that returns the data that you ask for. You can even weave data from different sources into one coherent graph of objects. GraphQL makes it trivial to do this seamlessly so that the client is oblivious to the provenance of the data it's requesting. And if you use reactive types, you can even get concurrent reads for relationships, which is nice because the total time to first byte for a collection of entities, each of which has another relationship, is not a function of n+1, but a function of 2, or maybe a little more. But there could also be still n+1 network calls, or, more. This is a problem because it's inefficient. I mean, it's the principle of the thing, right? And because it's expensive if your network usage is metered, as is typical in a lot of cloud environments. Thankfully, the core GraphQL Java engine comes with a solution here. Let's have GraphQL Java founder and lead Andi Marek tell us a bit more.
So, one common challenge when developing a GraphQL service or GraphQL API is that one query or one data fetching can lead to n follow-up queries. So the typical example is you query a person and this person has n friends, and so you have to query a person and then you have to query n friends. So this is where the name n+1 comes from. You need n+1 query if you really do it one by one. So this is such a common problem that a project called Data Loader was invented by Facebook alongside with GraphQL, and this project solves the n+1 problem by batching the requests together, and you only need two queries. Then you load a person and then you load all the friends to this person at once. So imagine if you would query a database, for example, you can make one statement to load the person, and then you can make another statement to load all the friends of this person. In Java, we have the Java Data Loader project, which is in spirit aligned with the JavaScript Data Loader solution by Facebook. But because Java is different than JavaScript in a lot of aspects, it was adjusted to the JVM and to the Java ecosystem. But fundamentally, it solves the same problem by batching requests together and giving you one call. In Spring GraphQL, it's via the batch mapping annotation, and that lets you load n things at once. The second benefit of using a data loader is the caching. A data loader caches element based on some kind of key, and it avoids loading the same object multiple times if it's already in the cache. So if you load a friend and then the friend of the friend and then the friend of the friend of the friend, for example, and one person is very popular and friend with each of them, data loader makes sure this person is only loaded once.
That sounds good for me. Could things get any better? Yep. The Spring for GraphQL project makes leveraging this facility as easy as possible in a Spring for GraphQL application. Here's Spring for GraphQL lead Rossen Stoyanchev with some of the deets.
So Andi talked about the underlying data loader mechanism to solve the n+1 problem. In Spring GraphQL, it's really about providing access and exposing that mechanism. We have the batch mapping methods that allow you to work with associated entities in a pretty straightforward way, essentially giving you a kind of syntactic sugar over the data loader without having to directly use it. But as always, we also make sure that you can access the underlying API, and it is possible as an alternative to using a batch mapping method to have the data loader injected into your query mapping method, and then you can use the data loader directly in a more custom, in a more hands-on way.
Isn't that amazing? The idea that it can just be built in from something so low level and foundational and just made a seamless part of the component model? I suppose you don't believe me. We have to kind of see it in action. So let's dive right in. So let's go ahead and build a new project. And here we're just going to call this batch. We're going to use Java 17. We're going to use 2.70 RC1. Nearly there. Oh, cannot wait, but we're almost there. Spring for GraphQL. Yep. And we want the reactive web support. Great. And I'll hit generate. And that's going to give me a project, which again, I'll just open up in my IDE. Okay, now, before we can get too far underway, we need to actually flesh out the domain a little bit. So let's go to the source directory here. So source main resources, create a new directory called batch. Call this, sorry, not batch, it's GraphQLS. GraphQL, and then a new file called batch.graphqls. And here, we're going to have a root type called query. And I want to get all of the customer data as before. It's an array or multiple values. So that implies a type called customer, which has an ID of type, whatever, ID. And then we'll have a name field. And then we'll have an account field. Okay, so account. And this implies that we need another type here. We're just going to call this ID. Very good. So somehow we need to get all the customers and all the accounts. Now, the nice thing about GraphQL is that we can stitch this together so that it looks like one aggregate from the perspective of the consumer, the client of this API. But behind the scenes, thanks to the magic of GraphQL and the decomposition that it affords us, we can actually source the data from different places. So let's call this batch controller. And first things first, I have to provide the implementation for customers. So we'll say add query mapping, and I'm going to return a collection of customer. Now, we don't have the type here, so let me create a record customer, integer ID string name. Yeah, good. I'm going to call this customers, and I'm just going to return, let's suppose we actually had, well, you know what? For now, let's just keep it simple. Just keep it all in memory. So new customer 1A, new customer 2B, and then we're gonna get all the accounts, right? We have an account type, so let's create another record here. So record account, and we just have this one property ID, so we'll just leave it like that. And here, like we saw last time, we can use schema mapping. We can say the type name is equal to customer, and we can get an account for each customer, which is the root of the aggregate there. So we say return new account customer.id. Now, of course, again, you would normally just resolve this using some sort of database, perhaps, or some other web service. You use the reactive web client, and instead of returning an account, you return a mono of account or something, right? Same thing for this. This could be a flux of customer. But for now, let's just keep it, as simple as possible. So we have the possibility, if you run this code, let's just log this out, getting account for customer.id, right? So let's go ahead and run this code. We also want GraphQL. We can actually, the graphical client rather. So I'm going to enable that, and then we're going to run the code or rerun the code. Okay, localhost, and we'll reload this. So query customers ID, great. Name, great, and account, great. Aha. So we have our customers. Each customer has its ID, its name, and its account, and then the account has an ID, and so we get that all back. What does the log say? Look at that. So that method got invoked twice, right? And this could be inefficient, right? This could be, this might be a network call. Here I'm getting the data from, I'm just conjuring up the data hard-coded, but this might be a network call. I might be calling JDBC. It might be calling another web service. I might be using, even the most efficient protocols like RSocket or whatever. there's still a network call. That's still another request that has to be made. That's resources that you may not want to waste. And you might actually have a more efficient way forward. So here, we have a representation of the schema that GraphQL is communicating to the client, right? The client is saying, the client thinks, oh, I can get all the customers, and for each customer, I can get the account, right? And that's true. That's the logical view that we expect to communicate to the client of the data. But behind the scenes, this is actually a different scenario, right? These services are independent. We might actually have account data in one table, and we might have customer data in another. These things don't logically live together in the same code base or same database or whatever. So it's useful to find a way to batch this request, to say, hey, give me all of the accounts for all of these customers. And that's where the Spring for GraphQL at batch mapping annotation comes into play. All you got to do is return a map of customer to a list of accounts, okay? So we say account, and then what I'm going to get as my parameter is the list of customers. Alrighty, so there's my batch mapping. I'm going to comment this out. This is no longer applicable. We don't need it, right? And my job is now, given all those customers, now I can, you can easily write this query, right? You could say select all from accounts where customer underscore ID is in parenthesis, and then the range of the list of customer IDs, for example, okay? And so this is much easier to do efficiently. There, you're getting all the customers, and then you're getting all the accounts for all the customers. Actually, in this case, I don't have more than one record, do I? I just have so I need for every customer, I need an account. If I had a 1 to n, then I would do that instead, okay? I would have a list of an account, but I don't. I have 1 to 1. Okay, so let's see, we can just, I'm not gonna, again, I don't need to write this all out. So actually, what's the easiest way to do this? We say customers, and then we want to map that data. So we're going to say customers.stream.collect, and we want to collect to map, collectors to map, and then we'll say for each customer, we're going to say customer, so that's the key, and then the value is for each customer, we want to say list, we want to say new account, and we just say customer.id, okay? Not a big deal. So there you go. There's our very simple map. What this is doing is I'm taking each customer, and for that, I'm creating a map of data. So var map, and you can see that map is equal to customer and account, okay? So that satisfies the contract. So let's go ahead and restart this, see what we get. Okay, go back here, rerun, and you can see I got the same exact data, except now, let's write this out. So calling account for customers, right? So refresh, there you go. So I got the same data as before, except now I'm getting all the data in one fell swoop. So now this is what used to be n+1, where n could be, 1,000, and therefore you'd have 1,001 network calls. Now it's just 2. You have 2 calls, one for all the customers and one for all the accounts that belong to that customer. And the client doesn't need to be any the wiser. And this is one of the nice things about GraphQL, is it makes it very easy for us to decompose the representation of the data from the storage of the data.
Isn't that amazing that such a facility could be built in such an elegant and high-level way for the GraphQL Java and Spring for GraphQL user? It's a little bit embarrassing for me, if I'm honest. I've spent so much time teaching people how to seamlessly build reactive processing pipelines over the last few years, teaching them how to do reactive service orchestration and composition. I love reactive programming, but GraphQL is sort of like SQL in that it's a higher level language that lets me describe what I want, and it will usually choose the most optimal path to get what I want for me. I say I want data from these various services, and it gives me callbacks. I don't need to worry about whether I run concurrently or not. GraphQL Java even makes it more trivial to maximize the benefits of reactive programming.
because it's implemented in such a way that it's agnostic of the web runtime. Spring for GraphQL then builds upon that flexibility. I only wish I'd learned about GraphQL, and I only wish we had Spring for GraphQL years earlier. It would have made life even easier. GraphQL and reactive programming offer some big wins. And because mutations are the same as queries, basically, you're almost all the way home when dealing with those as well. We're going to take a look at that in the next video.